In this video, we're going to talk about the multiplication rules of probability. And these rules are used when you're asked probability questions that involve successive events. And as successive events, those are just events that occur one after another. So for example, if I asked you to find the probability of flipping a coin and landing on heads, and then rolling a die and rolling a 2 on a die. So those would be considered successive events. And the probability of successive events depends on whether the first event affects the second. Sometimes it does and sometimes it doesn't. So the example that I just gave, when we flip a coin and then we roll a die, flipping the coin does not affect the probability of what I roll on the die. They're two separate events that don't, interact at all. And so if two events A and B are independent, we call these, then the fact that A occurs has no effect on the probability of B occurring. So this example of independent events that I just gave up here, that would be an example of independent events. So rolling or flipping a coin and rolling a die. Okay. If you have two events that are dependent, so they're either going to be independent or dependent. And if the successive events are dependent, it means that the outcome of A has some effect on the probability of B occurring. So an example of dependent events could be drawing one card from a deck, not replacing it, so keeping it, and then drawing a second card. And an example of a probability question pertaining to this experiment might be like, what's the probability of picking a king in the deck of cards and then a queen? And those would be dependent events. And so when we're asked these probability questions, we're going to need to use the multiplication rules. And so there are two rules, and these are similar to addition rules, where they're similar to each other, but there are some slight differences, and you're going to have to ask yourself whether or not the events are dependent or independent in order to pick which multiplication rule to use. And so if the events are independent, then all you have to do to find the probability of A occurring and then B occurring is multiplying those probabilities together. Okay, so let's do that. Let's do our example up here where I asked, what's the probability of flipping a heads and then rolling a 2? So if I want to find the probability of flipping a head, then a 2 on the die, what I'm going to do is I'm going to find the probability of flipping a head and multiply it by the probability of rolling a 2. And that's all I have to do because they're independent from each other. And so I think about flipping a coin. There are two choices. So there's a 1/2 chance that I flip a head. And if I roll a die, remember that with the die we have 6 different choices. So there are 6 possibilities and a 2 is 1. So there's a 1/6 chance that I roll a 2. And so the probability that I flip a heads and then roll a 2, I just multiply these fractions. And when we multiply fractions, we just multiply the numerators. So 1 times 1 is 1, 2 times 6 is 12, and then reduce the fraction if you can. In this case, we can't reduce, so the probability is 1/12, and then we're done. If the events are dependent, so the first one affects the second, then we have this formula down here, and it's similar to probability of A times B. It's just that this second part is going to be probability of B given that A has already occurred. I promise you it's easier than it looks. Basically, all you have to do here is really just make sure you're thinking about the situation. So when you find that probability of B, you factor in the fact that A has already occurred. So let's do this problem right here. So what's the probability that I roll it, or I pick a king in a deck of cards, times what's the probability that I pick a queen given I already picked a king first? Okay, so that already happened. So if I look at a deck of cards, there are 52 cards in a deck and there are 4 kings. So the probability of picking a king is 4 out of 52. Now I want you to imagine I'm taking that king and I'm setting it aside. So I did have 52 cards, but I picked the king and I set it aside. So now I only have 51 cards in the deck. So when I'm trying to find the probability of picking a queen, now there's only 51 cards left. Okay, and then I ask myself, well, how many queens are left? Well, I didn't pick a queen first, so there's still 4 queens left. So there's a 4 out of 51 chance of picking a queen. So because of the fact that I draw one card, I don't replace it, and then I draw a second, that's affecting the second fraction. And so this is how I would do that problem. So I would multiply those fractions together. So I would take, I could take my calculator and do 4 out of 52 times 4 over 51, and you don't have to use the n over d button. You could just divide 5 divided by 52 in parentheses and then times parentheses 4 divided by 51, and that would also work. And so I multiply these fractions and I get 5 over 633. Or 663 rather, sorry. Okay, so that's my probability for that one. All right, so let's go ahead and let's do another example. So in example 1, we have different color balls that are picked from an urn, which is just a bucket. The urn contains 5 red balls, 2 purple balls, and 5 white balls. A ball is selected and its color is noted, then it is replaced. That's really important. So when you're reading these questions and you see things like then it is replaced, you really want to highlight that. Because they tell you it's replaced, that means that they are independent events. Whatever they ask you about next. So a second ball is selected and its color is noted. Find the probability of each of these. So I went ahead and I drew out my sample space. I always like to do this if I can, and even if you have different colors, I think it's helpful to kind of understand what's going on. So in the first question, what's the probability of selecting 2 red balls? Because that first ball is replaced and these events are independent, we can use multiplication rule 1, where we just multiply the probabilities together. So the probability of selecting 2 red balls is going to be the probability of selecting a red times the probability of doing it again, selecting another red. And so all we have to do is we have to total these up. So there's 12 balls total. And we have to find the probability of each. So the probability of selecting a red is going to be 5 out of 12. And the second time picking a red, it doesn't change. It's still 5 over 12 because I put that first ball back. And so it's going to be 5 twelfths times 5 twelfths. You can multiply the numerator straight across. So you get 25 divided by 144. You can also, you can use a calculator. If you have the TI 30 or 34, you can use the N over D button and enter 5 twelfths times 5 twelfths. You can also use the squared button because 5 twelfths times itself is just 5 twelfths squared. So there's a lot of different options here. And then reduce this if you can, but in this case it's not reducible. So this is the lowest terms. And then the second question, selecting a purple ball and then a white. So we're going to find the probability of purple times the probability of white. So there are 2 purples, so 2 out of 12 chance of picking purple, and there are 5 whites, so 5 out of 12 chance of picking white, and so we multiply straight across. So we get 10 on the top, 144 on the bottom, and then both of these we can divide by 2 and get 5 out of 72, and that's the probability. And remember, you can always use your calculator to help you reduce too. Okay, so let's look at example 2. So in this example, it looks almost identical to the last example, but when we pick our first ball, we are not going to replace it. And then we're going to pick a second ball. And so because we're not replacing it, these events are dependent. So we have to remember that when we use our multiplication rule, we're looking at multiplication rule 2 now, which just means that we have to be extra careful when we find the probability of that second event. So for this first one, selecting 2 red balls. So I'm just going to write the probability of red times the probability of red, given that we've already picked a red. So we're going to do the first one, probability of red. So there's 1, 2, 3, 4, 5 out of 12. So times, and what I like to do is then, especially if you have this diagrammed on your paper, cross off a red. So take, your pencil, cross off a red, and then you can see, okay, now I have 11 balls, and there's 1, 2, 3, 4 reds because I already picked a red. And so it's going to be 5 12s times 4 11. So 5 times 4 is 20. 12 times 11 is 132. And then both of these are divisible by 4. So I'm going to divide both by 4 and I get 5 over 33. And then just a quick review in the calculator, if you have this kind of calculator, you could do 5 twelfths and then times 4 elevenths, and then I'm going to hit enter, and then this down arrow means it can be simplified, so you just hit the simplify button and keep hitting that simplify button until you see factor of 1, which just means that 1 is the only common factor, so 5 out of 33. And then let me show you how to do this with a graphing calculator. So I'm just going to use parentheses around each fraction and then the division sign. So 5 divided by 12 and parentheses, and then 4 divided by 11. And so I don't even need a multiplication symbol because that indicates multiplication. I get a decimal answer, which is also nice in case you want a decimal answer. And then I'm going to hit math, enter, enter, and that gives the fraction of 5 over 33. Okay, so let's look at the second question. So this one, we're doing the probability of selecting a purple ball and then a white ball. So I'm just going to write probability of purple times the probability of white. And if you want to write out given that purple already occurred, you can. I'm just going to keep that in my mind as I'm doing this. And so the other thing I want to do is I'm going to come and erase this X here because that was from the first problem. So I'm going to find the probability of picking a purple, which is 2 out of 12, and then I'm going to cross off that purple to indicate that I picked it. So I picked that purple ball. Now I have 11 balls left, and there are 1, 2, 3, 4, 5 white. And so I'm going to multiply these two fractions. So 2 times 5 is 10, and 2 times 11 is 132. And so I get 10 over 132. And then you can divide this or reduce. So just to review, so we could do 2 over 12 and then times 5 over 11. Just to make sure we got the right answer, you can see the down arrow indicates that you can reduce it, and you just hit that simplify button and you get 5 over 66, and just to be sure, hit it again until you see this factor of 1, and that just shows you, okay, you're down to lowest terms there. Okay, so our final answer is going to be 5 over 66. Okay, so let's look at this next example 3. So a different situation here. So a coin is flipped and a die is rolled. Find the probability of getting a heads on the coin and then a 4 on the die. Are these independent or dependent events? Really good question. So because the flipping of the coin has no impact on what is rolled on the die, we say these are independent events. So all I have to do is find the probability of getting a heads and multiply that by the probability of rolling a 4. So the probability of getting a heads, if I have 2 choices, tails and heads, is 1/2, and the probability of rolling a 4, if I have 6 choices, would be 1 out of 6. So then I multiply those together. 1 times 1 is 1, and then 2 times 6 is 12. So the probability of those events happening in order is 1/12.